Welcome to a new video with new problem. In this video, we are going to solve a problem from LeetCode which is called find all the numbers disappeared. So this problem is of a easy category and the number for this problem I'll mention is 448 on LeetCode. So you can find it there and you can solve it there. So this question has been asked in interviews and this is an array problem. So what it says that we are given an array of size n and such that all the elements that are present in this array will lie between 1 to n, where n is the size of the array. So that means, let's say if we have an array of size 5, so all the elements that would be present in the array will lie between 1, 2, 3, 4, 5. So anything, it could be anything between 1 and 5, right? So let's take the example. So we are given an example where we are given some elements and some elements are missing from this array. So we have to return those elements. So let's see. As you can see that in this array we are given elements which range from 1 to 11, and in this we are missing two elements, that is 6 and 10. So we return these two elements, right? So how we can do this? See, there can be multiple approaches to solve this problem, but starting from a very basic approach, that would be a sort approach. Like, let's say when you are facing an interview and in their interviewer asks you this question, then you will start with the most basic approach that you can think of. That would be a brute force approach or anything. So sort is like a very basic approach here. What you can do, you can sort all the elements. I'll not go into much detail, but I'll just quickly explain how we can use sort here. So yeah, if you want to, let's say, find solution using sort, so what you can do, you can sort the element in ascending or descending, however you want, and then you can simply check the next elements from the current index, right? If you don't find those elements, then simply insert in a list or add it in an array and return the array. So this approach will take the complexity of O and log n, considering that we use merge sort here, and space complexity will be O of n if we want to add the elements in a list. So clearly you won't want to finish your question, finish your solution with this approach. So you would probably want to optimize it such that you can solve this in linear time, and you can maybe use less space, less extra space, maybe in constant space. So the next approach that I would come with in an interview would be using a hash map or hash set. So using a hash set, how we can do it? So hash set is nothing but a collection or a map of all the elements, like a key value pair, right? So what I would do, I would first iterate over this array. So I would loop over this array, and then I would simply put all the elements in my map. Okay, so I would put all the elements in my hash set. So I would do simply one add operation. So this would be O of n. Okay, and now how do I find that what is not present, like what elements are not present here? So for that I would simply check that hash map dot contains. Okay, so if this is true, then good, keep move forward, right? If it is false, that means the element is not present, right? So what does that mean? Like if that element is not present, then that will be our potential answer. So we will simply add it to our list. Okay, so we'll have a list initialized for our result, like a list of integer for result, and then we will simply add it in result dot add and the element which are not present. Okay, so this is my hash set approach. But if you notice that for using hash set and using a list, we'll need O of n space also for maintaining a hash set. So let's say if the interviewers want you to use constant space, like solve this in constant space, then how would you proceed? So for that, we can start marking what elements have we visited. So how we can do this? Where we can solve this problem in linear time and constant space. So we are given this example, we are taking this example only, and in this we will try to solve, find all the elements which are missing. So what we know here, that the size of array, let's call this array as ARR. So we know that we can find the size of array, right? and we can somehow figure out that we have visited the elements. Let's say if I start looking from index 0, so what I will have to do, I will have to mark it that I have visited it. So for that I can do two things. Either let's say if I visited 9, so I'll negate it. I'll put a minus sign in front of it. If I visited 7, so similarly for all the elements which I have visited, which are present and which I have visited, I'll put a negate sign, like I will negate it. So what will happen when I'll have to check that what elements I have not visited? So that means in the range of 1 to 11, only those elements will be missing who are non-negative, right? So what I'll have to do, I'll have to loop it from 1 to n, and inside that I'll have to check that if array of my current position is greater than 0. If it is greater than 0, then what I'll do, I'll have a result array and I'll add my current elements in that. So I will do something like this. Wait, result dot add, and then I'll have to add the indices. Now why I have done I plus 1? If you look at it carefully, see, we are given that our array starts from 1 and goes to n, right? So to compare with the normal index of array, which starts from 0 and go to n, what we'll have to do, we'll have to make it I plus 1. So did the same thing here. Now let's go quickly to the code part. Let us start with the first approach, that is HashSet approach. In this approach, we are using O of n space, that is linear space. And to start with the code, first I have created a numbers HashSet, and after that I have created one result array list. So this is a list of integer. So what we have to do, we have to first traverse in this like this array. So for this, like I have simply added all the elements which are present in this nums array, which is the given array, and so this is how I created my HashSet. Okay. So further, when I want to check that if some number is present in my HashSet or not, so what I'll have to do, I'll have to quickly iterate through my array, and then I'll have to check that if that index is contained in my HashSet or not. If that is not contained, like I have written here, if my HashSet doesn't contain any particular index, so I will add that index in my result list. So you can also notice I have written I plus 1 here. So again the same logic which I explained earlier, that my index starts from 0 in array, but the numbers we are given here are in range of 1 to n. Okay, so that's why I added like the next index. So this is how we can use the HashSet approach. Next we can see our other approach where we are using the constant space. So for this solution, for this approach, what I have done, I have created one result array, and then I have traversed through the numbers like the input array, and for every element that I have visited, I am basically marking it. How I am marking it? I am simply putting a minus sign in front of this. So what you can do here, you can come, when you are at a current index, okay, let's say the index name is visited element. So I'll go back one index previous to that, and I'll simply put one minus sign in that. Also, one more thing to notice here, that why I have used absolute. So math.absolute is used because we can have repeated elements here present. So to avoid those things, we are just taking the absolute values for that. And let's say we have now marked all the elements which we have visited. So how we can check that what elements are not visited yet? So you can see that all the elements which are visited are negative now. So any element which was not visited by us or which is not present in the input element should be positive in while checking in the array. So for that, what we can do, we can simply loop over our array, and then we can check that what indices are greater than 0. If let's say if there are some elements which are present, so that would be minus by now. But if those are not minus, that means they were absent in our input array. So what we can do, we can add the indices in our result, and then we can return the result. So this is how we can solve this in constant space. I hope you understood how we can solve through all those three methods: sort, by sort approach, and then by HashSet, and then by this approach. So thank you for watching.